Welcome back. We've seen that the average temperature around the globe has gone up about 1.2 degrees Celsius, or about 2.2 degrees Fahrenheit, since about 1900. In this session, we're going to look at the consequences of such a temperature increase. We'll start with changes observed in glaciers and ice sheets around the world. We'll then show how all this warming has impacted the oceans. During these last few years, we've also witnessed more extreme weather events, so we'll take a look at those as well. By the end of this lesson, you should have a pretty good sense that while 1.2 degrees doesn't sound like much, it certainly is having a significant impact on everything around us. Let's get started. The increased temperatures, particularly in the north, are causing significant changes to glaciers, ice sheets, and sea ice. These images show the Pedersen Glacier in the Kenai Mountains of Alaska. Just 100 years ago, the glacier extended all the way to the water. Today, the glacier has retreated back into the mountains, leaving behind a grassy meadow. And this is happening all over the world, and not just with glaciers. Arctic sea ice, for instance, grows and shrinks every year with the seasons. Scientists worry about the minimum in sea ice and its ability to recover during the winter months. Unfortunately, in 2019, the minimum in ice extent was the lowest ever recorded. Ice sheets, such as the one covering Greenland, are also shrinking. So how much of a problem is all this? Well, glaciers are often a source of fresh water for people. And without healthy glaciers, there's a lack of water for drinking and irrigation. Melting ice sheets, such as the one covering Greenland, are especially problematic, because when ice that is currently covering land melts and flows into the ocean, then we see ocean levels rise. Losing ice and snow has another consequence. Just like any other white surface, ice and snow reflect a lot of the sun's energy. But once this is gone, as you can see in the image, the darker earth or ocean absorbs more of the sun's heat, and things start to warm up even faster. We know the air around us is warming up. It turns out a lot of the heat from the sun ends up warming the oceans as well. In fact, it is estimated that 90% of the warming that has happened on Earth over the last 50 years or so has occurred in the ocean. This means that if it weren't for the oceans, the air temperature would be a lot hotter than it already is. The plot on this slide shows just how much the surface temperature of the ocean has changed from pre-industrial times. Just like we saw with air temperatures, the average temperature at the surface of the ocean has increased slightly more than 1 degree Celsius, or nearly 2 degrees Fahrenheit, since about 1900. We can be pretty confident about this, too. The lines on the graph come from several different organizations that specialize in these kinds of measurements. And as before, they all agree remarkably well. Another important observation has been the steady increase in sea levels for more than 100 years or so. As this graph shows, sea levels have increased more than 240 millimeters, or about 9 inches, since 1880. You also see two sets of data plotted here. The light blue line that goes back to 1880 uses measurements from tide gauges. The dark blue line from about 1970 is based on satellite measurements, a more accurate way to measure sea level. Yet they agree rather well, telling us without much question that the sea level is indeed increasing. The other thing to note is that the data curves upward slightly. That's telling us that the rate at which sea level is increasing is also going up. In fact, between 2006 and 2015, the rate doubled, from the average across the 20th century to more than 3.6 millimeters, or more than 1/8 of an inch, each year. Now, maybe 1/8 of an inch doesn't sound like much, but take that over a few decades and centuries, and now you're talking inches and feet of sea level rise. And that gets a lot of people in coastal areas very worried. It turns out that sea level rise is due to two primary factors. One, just like about everything else, when something heats up, it expands. So part of the sea level rise is due to thermal expansion from the warming ocean water. The other effect is from the addition of water coming from melting glaciers and other ice sheets that cover land. The curve in this slide shows the rise in sea level from 1993 to 2018, about when we started measuring ocean sea levels with highly accurate satellite systems, the dark gray line. Scientists are able to estimate how much of the sea level rise is coming from thermal expansion effects and how much from added water. The red line is the increase from thermal expansion, and the blue lines that overlap each other are from several estimates of added water. The purple line at the top is the combination of the red line and the blue line estimates, and agrees rather well with measured data. We can see that over the last 15 years or so, the contributions from adding more water to the oceans has started to dominate the reason for sea levels rising. That trend is expected to continue if we see more melting of glaciers and land-based ice sheets. Now, if sea levels are rising, we would expect to see the likelihood of more flooding occurring in areas near the coastline. And in fact, this is exactly what we see these days. High tide flooding near many U.S. coastlines is between 3 and 9 times more frequent than it was just 50 years ago. But we're seeing strange and somewhat extreme weather events everywhere. The combination of higher ocean temperatures and higher land temperatures is changing the weather in all sorts of ways. 2020, for instance, saw extensive flooding in Asia and Africa, and unusually high amounts of rain in many parts of the United States led to flooding that wiped out farms and towns that were far from the ocean. But it's a real contrast depending on where you live. While some regions experienced extensive flooding, other areas experienced unusually hot and dry periods, leading to severe drought. For instance, parts of Argentina recently experienced the second driest January through August period on record. Many locations in South America had similar drought conditions. And if there is no water, then you can't grow food, leading to an increasing food insecurity. This is particularly true in poorer regions of the world, where malnutrition due to drought conditions is impacting the daily lives of millions of people. Hot and dry conditions also result in a greater number of wildfires. Many of you might recall the devastating images of the fires in eastern Australia during 2019 and early 2020. These massive fires impacted thousands of people, and the toll was even worse for the wildlife, where it's estimated that nearly 1 billion kangaroos, koalas, and other animals lost their lives. Many of us are also aware of the wildfires in California. It seems like there is a major fire every year now, and in some cases burning down entire neighborhoods and towns. Yet things are getting worse over time. The higher temperatures and drier conditions mean even more fires than before. And the scope of the fires is increasing as well. In 2020, California and Colorado had the largest fires they've ever experienced. Warmer ocean temperatures and warmer land temperatures also lead to extreme weather events such as hurricanes, more of them and with greater intensity. During the 2019-2020 storm season, more than 96 named tropical storms occurred around the globe. 30 of these storms occurred in the northern Atlantic, with 12 of them making landfall in the United States, leading to billions of dollars in damage and many lives lost. In fact, there were so many storms that we ran out of names for them, resorting to Greek letters like Eta and Iota. If temperatures continue to increase, we can expect to see more of what we saw in the last few years, a greater number of hurricanes and more severe hurricanes.